This video is about more practice for graphing rational functions continued. When you graph rational functions, remember that rational functions never cross vertical asymptote line, but may cross horizontal asymptote line and oblique asymptote line. Therefore, when there is a horizontal asymptote line, y equals a not equal to 0, or oblique asymptote line, you need to check where the intersection is. Now let's go to number 4. First of all, we need to factor these rational functions. We got the x minus 4x plus 2. For denominator, we do ninja x, negative 6 over 2 over 2 and negative 5. So we get the negative 6 and 1. Negative 3 over 1. Reduce, so we get the x minus 3, then 2x plus 1. For domain, we set up a denominator not equal to 0. So we get x not equal to 3 and negative 1 over 2. Since we don't have common factor, therefore, the vertical asymptote line will be x equal to 3 and x equal to negative 1 over 2. For horizontal asymptote line, we do the limit. Check the ratio of leading term. That will be 1 over 2. So y equals 1 over 2 will be the horizontal asymptote line. Oblique asymptote line is not available. For the roots, we got the 4, 0 and negative 2, 0. For y-intercept, we plug x equal to 0 to this rational function. This is 0, 0, 0. So we got 0, 8 over 3. Whole not available because we don't have a common factor to be reduced. Now let's draw the number line. Negative 1/2 and here's a 3. This is a vertical asymptote line. For the roots, you have a negative 2 and a 4. For y-intercept, that's a positive. Positive. So change the sign for the neighbor interval because all the factor in this rational function are single factor. So change the sign like this. For horizontal asymptote line, that's y equals 1/2. Now we can sketch the graph. When x greater than 4, positive. But we don't know the graph will intersect this horizontal asymptote line or not. Therefore, you need to work on the intersection of a rational function and a horizontal asymptote line. Therefore, we set up x squared minus 2x minus 8 over 2x squared minus 5x minus 3 equals 1/2. Then we do cross multiply. You will get the 2x squared minus 4x minus 16 equals 2x squared minus 5x minus 3. Combine like terms. Add 5x, then add 16. You will get the x equals 13. In other words, 13 and 1/2 will be the intersection of horizontal asymptote line and the graph of a rational function. Suppose this point is 13. Then we'll cross this horizontal asymptote line. Then remember, it will go down, then very, very close to this horizontal asymptote line. For the horizontal asymptote line, which means when x tends to positive or negative or infinity, the graph will be very, very close to 1/2. Between 3 and 4 is negative, that's why it's go down like this. Between negative 1/2 and 3 is positive, so we graph like this. Then between negative 2 and negative 1/2, that's a negative, so go down like this. Then it's a positive, it's very, very close to this horizontal asymptote line, but don't cross. Now we will sketch the graph on the graphing paper. X equals 3. This is the one. So x equals negative 1/2. Roots, that's 4, 0. Here. Negative 2, 0. For y-intercept, that's 8/3 means 2.6 something. Therefore, we have here. Y equals 1/2 will be this one. Then find the 13 1/2. Now we can sketch the graph now. This is the real graph for number 4. You could say the graph of this rational function cross this horizontal asymptote line at x equals 13. Now let's go to number 5. First of all, we reduce x minus 5, x minus 5. We got the x minus 4 over x plus 2. This time, you have to be very careful. We call this is the original function. This will be a simplified function. For domain, we make a original function that denominator not equal to 0. Therefore, x not equal to 5 and negative 2. But for vertical asymptote line, we go to simplified function. Make denominator equal to 0. We only make x plus 2 equal 0. That means x equals negative 2. Please remember, only domain you have to use original. For rest of properties of rational function, some you have to use simplified, some you can use both, but still simplified will be easier. So I recommend that you use simplified to figure out properties except domain. For horizontal asymptote line, that's a limit of a leading term. You get x over x equals to 1. Thus, you get the y equals to 1. For oblique asymptote line, none. Because keywords is 1 more degree, it's not. For roots, you will make a numerator of a simplified function equal to 0. Therefore, you get the 4, 0. y-intercept, I will put the f of 0. This will be 0, this will be 0. Negative 4 over 2 get negative 2. So you get 0, negative 2. For the whole of a rational function, common factor is keyword. We do have a common factor that's x minus 5. We set up this one equals 0. X equals to 5. Then we plug 5 into this simplified rational function. 5 minus 4, 5 plus 2. So you get 1 over 7. 5, 1 over 7 will be the whole of this rational function. For simplified rational function, since this is a linear over linear, that will be one of these two graphs. Either like this one or like this. Since this two is pretty easier to graph, we don't have to use a number line to predict. We got asymptote line, x equals negative 2. And y equals 1. Then plot the intercept. We got 4, 0 here. Y-intercept, that's 0, negative 2. It's here. We got the whole. So you will plot this 5, 1 over 7. You got to use an open circle here. Then we could say it will be this pattern. So we connect these 3 points. Remember, this part is an open circle. And you can sketch the graph on this side just like this. That's all. This is a real graph for number 5. Let's go to number 6. We still factor the top. You got x minus 4, x plus 1 over x minus 5 squared. For the domain, since we didn't reduce common factor, original function will be same as a simplified function. Domain, we make denominator not equal to 0, so x not equal to 5. Vertical asymptote line means that x equals to 5. For horizontal asymptote line, that's a limit of leading power. So we got x squared, and also this is x squared. You will get 1. Y equals 1 will be horizontal asymptote line. No oblique asymptote line because it's not 1 more degree. Roots, you will make a numerator equal to 0. Therefore, 4, 0, and a negative 1, 0. Y-intercept, you will plug f of 0 to the function. Whenever you say x, that will be 0. So we see this is 0, 0, this 0. You will get negative 4 over 25. Then you get 0, negative 4 over 25. No common factor. There's no whole for this rational function. Now we use number line to sketch this rational function. We got negative 1, 4, and a 5. X equals to 5 is a vertical asymptote line. Negative 1 and a 4 are roots. So there we use the big dot. The graph will pass through these 2 points. 0 is here, then this will be negative because negative 4 over 25. Then check negative 1. Factor is x plus 1. This is a single factor, so we change the sign. 4 still is a single factor, we change the sign. Look at the 5. I got x minus 5 squared, which means no sign change for neighbor interval at 0 equals 5. So this still positive. Now we add horizontal asymptote line y equals 1. It's above this x-axis like this. On the very right side, and we will predict the graph like this. Positive means above this horizontal asymptote line. For this 4, positive means we will go to cross this horizontal asymptote line. Negative, that's going down. Then positive, we go to this way. We want to figure out what's these points. So I will set up, this is the one. X squared minus 3x minus 4 over x minus 5 squared equals 1. Because the horizontal asymptote line, that's y equals 1. We solve this equation now. We will get the x squared minus 3x minus 4 equals, multiply by x minus 5 squared both sides. You will get the x squared minus 10x plus 25. So x is gone. Then you can get 7x equals 29. X equals 29 over 7. Therefore, for this point, it will be 29 over 7, 1. Now we sketch asymptote line first. This is a 5. And y equals 1 like this. Then plot intercepts. 4, 0 is here. Negative 1, 0 is here. 0, negative 4 over 25, that will be here. That's intercept. So we can sketch the graph this side like this. This one over here like that. And then connect these points. So go this way. This will be the graph for number 6. This is the real graph for number 6.